So today we're going to talk about area of trapezoids. As long as you know the formula, it's not that bad. This is probably the most complicated formula that we'll deal with in this chapter. And I'm going to spend a few minutes breaking it down so you know exactly what to use to fill in what letter. All right. So for trapezoids, remember, those are kind of like our triangles that had their heads chopped off. They have one set of parallel sides and then the other set can kind of do whatever. So the formula is area equals 1/2 times the height times the sum of the bases, base 1 plus base 2. So this reads 1/2 height times base 1 plus base 2. I'm going to show you what that means. I have a picture. This is in your book, but I'd rather you just watch this in a couple minutes. I'll have you get your book so you can follow along. So I'm actually going to take a pink pen, and anything that is the height, I'm going to mark in pink. And anything that is a base, I'm going to mark in green. Okay, hopefully you can see that. Now, this says base 1 and base 2. They are usually two different numbers, but it doesn't matter which one you put in here. In the same exact problem, I could call a number base 1, and you might call that number base 2. But then what you put here, I would put here. It's just a way of saying these are the two bases, the parallel lines. They're the ones that go together. We have to distinguish them because if we put b plus b, they would have to be the same number, and often they are not the same number. So that's why we have b1 plus b2. All right, so let's look at this. Here is a trapezoid. So I'm looking for the height. Just like in triangles and parallelograms, the height will always be perpendicular. So the height will be the distance between those two lines. All right? The bases are the things that are parallel. So it would be that one and that one. The other two sides for area really don't do anything for us. They just look cute and hold the two things apart. All right, so this could be base 1 and this could be base 2 for me. Maybe you flip it around and you say this is base 1 and this is base 2. It doesn't really matter. Commutative property for addition lets us switch them around. All right, so on this one, the bases are the parallel. So it would be this one and that one. And I would count them because they're on a grid if the number wasn't given to me. And then I'm looking for a line that is perpendicular to both of them, straight up and down. In this case, it would be there. It wasn't drawn in for me. I just had to count. The two slanted sides really aren't going to do much for me. Okay. All right, let's slide down and practice a couple more here. Now, if you notice, both of our sides here were slanted. When we get down to these, only one side is slanted and the other side is actually our height. So perpendicular, this is going to be the height. And these will be the bases. Again, that slanted side doesn't really do much for me. If I come over here, bases are parallel. The height could be marked over here, could be marked over here. It doesn't matter. It's perpendicular. Okay, and then two more. Notice I'm not calculating these. I just wanted to spend a few minutes practicing finding the different parts of a trapezoid. So that would be the height. Over here would either be the one marked 9 or it would be the dotted line. Doesn't matter. Those are the heights. And then the bases, B1 and B2, B1 and B2. All right. Now, in your book, I would like for you to turn to page 686. We're actually going to work through finding the area of a trapezoid. So, this is my height. These are my bases. I'm going to write out my formula. So area equals 1/2 height times base 1 plus base 2. All right, let's go fill it in. I don't know the area. The 1/2 stays. The height we said was 7. The bases are 5 and 12. And you notice if I had put 12 plus 5, or if I kept it as 5 plus 12 as I have it here, it doesn't matter. We're still going to get 17 for the inside. All right. Now, most of us are going to reach for a calculator, and that's okay. If this were an even number, like say this was 8, I would probably cut that in half before I multiplied, but these numbers are going to get like this is 17 times 7, and then cut that in half. It's going to get pretty big. So let me grab my calculator real quick. You know that you can do 0.5 for a half. 0.5 times 7 times 5 plus 12 is 17. I get 59.5 inches squared for my area. I got the inches here, and because I'm finding area, it's inches squared. So that's it. As long as you know what the height is and what the bases are, you know your formula, you just replace what you can, substitute, and then multiply it. Well, add, then multiply it, and that'll give you your answer. Okay, let's shift over to the next page up at the top. I know the book does it for you. It's actually really pretty. They do it in light colors, but I want you to see me work through this. So the formula, area equals 1/2 height, base 1 plus base 2. Let's mark off some things. Our height, now this one's outside. They could have done it in here. It doesn't make a difference. It's the one that's between and perpendicular. There's a base. There's a base. So let's fill in some numbers. I've got 1/2 times my height is 9.8. The bases are 7 and 12. So 7 plus 12 is 19, whether you switch them around or keep them as it is. 0.5 times 9.8 times 19 equals 93.1 meters squared. Now, if you don't have a handheld calculator, you can get online and just search calculator. You can pull one up. I'm sure there's an app you can pull up on your Chromebook. Okay, there's some got it problems that you can try. If you need feedback on those, I can put the answers up for you. You can email me. I want to talk about this. Now, sometimes they give you the area and ask you to find one of the missing measures, specifically the height for this. This is a little bit more complicated. You can absolutely still use this and then just kind of undo like we've been doing with solving equations. But they give you what they call a related formula. So if you're asked to find the height, I would flip back and use this particular formula. All right, so I'm just going to work through one of these just so that you've seen it. We're going to really focus today on finding the area when you know the height and the bases. This is just something a little bit extra. So I'll recopy my formula. Height equals 2 times the area over base 1 plus base 2. My height here is unknown. My bases, and they tell me the area. All right, so let's replace what we know. I don't know the height. The area was 108. Actually, I'm going to multiply that with an X or a star or something. Try to make it better, and I made it worse. And then on the bottom, I'm going to have 12 plus 15. All right, so 2 times 108 is 216. 12 plus 15 is 27. I'll grab my calculator because I don't know that off the top of my head. It looks like it's going to be about 9 something. 216 divided 27 equals, close enough, 8. Now, this one would be plain 8 feet, not feet squared. All right, because we're only finding the height, and I'd measure it with just a regular ruler. I would not use squares like I would for area. All right, so if you need to do one of these, you can come back and look at the example. They've worked it out just the same under there. All right, so that will still be there for you. But we're going to concentrate mostly on finding the area when we're given the height and the basis.